Hello everyone. In this video we're going to be solving a cubic equation. Not an ordinary one, a special one. We have x cubed minus x minus 2 quantity squared equals 60, and we're going to be solving for x values. Now these types of problems I think we've done before, at least once. So hopefully you'll remember the strategy, but notice that we have an interesting scenario. We have a perfect cube and a perfect square, and they are being subtracted. So it's kind of like, you can't really call this a difference of two squares or difference of two cubes. It's the difference of a cube and a square, which is kind of weird, right? But actually, that's a good thing. All right, I'll be presenting two methods, and let's start with the first one. So my first method is usually very straightforward, just expand everything. X cubed, if you subtract from it x squared minus 4x plus 4, and then set it equal to 60. Let's simplify this. X cubed minus x squared plus 4x minus 4 equals 60. Let's put everything on the same side. X cubed minus x squared plus 4x minus 64 equals 0. Now, it would be really nice if this was factorable by grouping, don't you think? For example, take these two and take those two. Factor out x squared, you'll get x minus 1. Factor out 4, you'll get x minus 16. Uh-oh, it did not work, obviously. It wouldn't be that easy, right? So what do? We need to do something else. Factoring by grouping. You should always try it, though, because you never know. It might just work. So we're going to try a different thing. Like, let me rewrite the problem. Maybe something like a rational root theorem. Remember rational root theorem? We talked about it. I also call this RRT. Basically, it just says that if we have rational roots, they're basically formed by dividing the constant term by the leading coefficient. But in this case, the leading coefficient is 1. So if we have rational roots, they need to be integers, which means they're going to be factors of negative 64. Positive or negative doesn't really matter because we have to consider all possibilities. And since 64 is 2 to the 6th power, we're going to be looking at plus minus 1, plus minus 2, plus minus 2 squared, which is 4, plus minus 8, so on and so forth. Basically, all powers of 2 up to and including 64 with the plus minuses. And good luck checking those because there's going to be quite a few. I believe there's going to be 14 factors that you need to check because 2 to the 6. 6 plus 1 is 7, double that because we're also considering the negatives, right? You hopefully know how to count the number of factors. It's pretty easy by looking at the prime factorization. Anyway, so if there are any integer solutions, which we should hopefully have, right? Then it's going to be one of these factors. But again, checking these is going to be time consuming, but hey, sometimes that's all you have to do. But there must be a better way to solve this problem, especially if you consider that this problem might have appeared because similar problems appeared on math competitions before. And sometimes problems repeat themselves, or, you know, one math competition will, get the idea. I don't want to call it steal the idea, but, people always get ideas from each other, right? Even on YouTube, you've probably seen that a lot of videos are, same problems are circulating. And some of them are even being labeled like Olympiad problem, math Olympiad problem, negative 2 to the x power is equal to negative 4 or something like that. Anyways, they're not Olympiad problems, by the way, but that's a different topic. So what do we do with this? Let's go ahead and talk about the second method. Enough ranting about other things. Let's go ahead and take a look at method number 2. So we have a problem which is designed specifically for the second method, of course, right? So the fact that we're given the difference of a cube and a square is not by chance, or it's not coincidental. It's on purpose, okay? And the idea behind this is to get a sum or difference of two cubes on one side, and then to get a difference of two squares on the other side, so that those two polynomials have a common factor. You get the idea? That's the outline. But wait a minute, we don't know sum or difference of two cubes, but we know difference of two squares, because if you have sum of two squares, it's not going to be factorable unless you use complex numbers, right? So we want that to be difference of two squares. So let's go ahead and start by moving the square to the right hand side. Now here's what I need. I do need to subtract some number from this, a perfect square from this number. So what are the possibilities? I could be subtracting 1, I could be subtracting a 4, I could be subtracting 9, 16, 25, 36, so on and so forth, right? Let's test some of these. Because what's going to happen is when you test these, you're going to see that most of them won't work. But how would you know the one that works? Because a lot of times if I bring up the solution right away, I'm like, how on earth you came up with this, right? Well, because I came up with the problem, I knew the solution, and I worked backwards to give you the problem, right? Obviously. So that's kind of unfair. Let's just pretend that we don't know how to solve it, or I don't know how to solve it. I would probably just test out, start with 1. 1 is probably unlikely, but anyways. So here's what I'm going to do. I'm going to subtract 1 from it to make it factorable, but then I do need a 60, so I would have to add 61. You know where that 61 is going to go? It's going to go here. And as a minus sign, it's supposed to give us difference of 2 cubes, right? Well, if it goes as a plus sign, and then it can give us, but 61 is not a perfect cube. So minus 1 failed. Let's try another one. How about 4? Okay, minus 4 requires the addition of what? 64, right? Great. So that makes a 60. That's good. You know why? Because if I bring the 64 over here, 64 is 4 cubed, and that is going to make difference of 2 cubes. Maybe minus 4 just worked, right? Who knows? Let's test it out. How about 9 though? I'm curious. Maybe more than one number will work, which is very unlikely, by the way. But in this case, I do need a 69. Uh-oh, that's not good, because that's not gonna make a perfect square. So that's not good. Minus 9 is not gonna work. Minus 16 is not gonna work. I don't think any of these will work. How do I know that? Because again, I know the solution, right? So let's continue or proceed with this number. So now we have the following. X cubed, I'm gonna bring the 64 over to the left, minus 64. And then on the right-hand side, hopefully this made more sense, as opposed to me just giving you the solution, right? And now we have the following. This is x minus 4, difference of 2 cubes. Remember the formula, a squared plus ab plus b squared. And then this is difference of 2 squares, x minus 2 minus 2. Remember, this is 2 squared, so you have to take it as a 2, times x minus 2 plus 2. I could have written the plus first, but who cares, right? This is x minus 4, beautiful. And x minus 4 becomes a common factor. So we can take it out. And now this is on the left-hand side with a minus sign. The other factor is just going to be, this is going to be, really? Is that x minus 2? It's just going to be an x. Okay, fine, whatever. It's going to be a minus x. Okay, cool. I guess that's what it is. I'm like, what? Is it really x? Maybe that's it, because you know what? If you expand it, you're going to get x squared minus 4x plus 4 minus 4. Then it's going to be x squared minus 4x. Exactly, that's right. Couldn't we get that directly from here? Yeah, I guess we could manipulate it that way. Anyways, so now we have a 0. Cool. X minus 4 is a factor, we know that. And then we get x squared plus 3x plus 16 equals 0. And from here we should get solution. Obviously, x equals 4 is an integer solution. We could have found it using rational root theorem, but that would be a little harder. Negative b plus minus the square root of b squared, 9 minus 4ac. Uh-oh, we get an imaginary complex non-real solution. Okay, whatever you want to call that. But from here we're going to get negative 3 plus minus the square root of 55i over 2. So there will be 3 solutions, because this is a cubic. And this brings us to the end of this video. Thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe, take care, and bye-bye.